Why new methods are vital to reducing the environmental and human health impacts of traditional semiconductor manufacturing. Dr. Maxim Plakotniuk is the CEO and founder of Atlant 3D, a pioneering deep tech company at the forefront of innovation, developing the world's most advanced atomic scale manufacturing platform. Maxim is the inventor of the first ever atomic layer advanced manufacturing technology, enabling atomic precision development of materials, devices, and microsystems. A scientist with a PhD in nanotechnology, he has deep expertise in nanotechnologies, renewable and exponential technologies, semiconductor processing, solid-state physics, and material science. A Fulbright scholar, Hello Tomorrow Grand winner, and proud Ukrainian, Maxim has earned global recognition for his work. Global demand for semiconductors is showing no signs of slowing down, with the U.S. alone expected to triple its semiconductor manufacturing capacity by 2032. However, the industry faces a serious dilemma. On the one hand, semiconductors are the core component of many exciting new eco-friendly developments, like electric cars and environmental sensors. On the other hand, we have to ask ourselves if this explosive growth is worth the environmental trade-off. In fact, according to one concerning study, traditional manufacturing involving electronic communication devices accounts for almost 75% of the world's total CO2 emissions. Traditional manufacturing methods rely heavily on high temperatures, harsh chemicals, and cleanroom infrastructure, contributing significantly to energy use, emissions, and toxic waste. As the industry expands, it faces an urgent challenge: how to scale responsibly without compromising environmental and human health. This is going to be especially critical as the USM, a very environmentally focused nation, looks to increase domestic chip production and increase its own strategic resilience in light of possible tariffs. New advanced manufacturing techniques are the answer. New advanced semiconductor manufacturing techniques can help create more environmentally and human health-friendly products. One of these emerging techniques is localized direct atomic layer processing. This surface-controlled layer-by-layer process results in the deposition of thin films, one atomic layer at a time. This technique is helpful in the following ways: reducing heat. Unlike conventional methods that expose entire wafers to elevated temperatures, localized direct atomic layer processing applies materials locally with atomic scale precision at significantly lower temperatures. By eliminating the need for the high-temperature, high-vacuum processes used in traditional semiconductor manufacturing, localized direct atomic layer processing can reduce heat generation by up to one-half compared to more conventional methods, and without compromising quality or throughput. Lower heat needs also directly translate to reduced energy demands during fabrication, which lead to lower CO2 emissions and reduced thermal management needs. By slashing heat requirements, localized direct atomic layer processing enables a more energy-efficient pathway that contributes to broader climate goals, cutting emissions, curbing energy waste, and ultimately mitigating industrial contributions to global warming. Supporting decarbonization. Localized direct atomic layer processing enables centralized digital atomic manufacturing compared to traditional fabrication methods that are decentralized, multi-step, and slow. By reducing energy consumption, material waste, and reliance on centralized cleanroom infrastructure, localized direct atomic layer processing supports decarbonization at every stage of the process, from prototyping to full-scale production. The technique empowers manufacturers to adopt cleaner, more agile fabrication processes that align with net zero targets, while accelerating innovation in electronics, aerospace, healthcare, and other industries. Minimizing chemical use and exposure. Localized direct atomic layer processing doesn't just minimize heat and energy use, it also drastically reduces chemical use and human exposure to those chemicals. The semiconductor manufacturing process has traditionally involved heavy chemical use by flooding an entire chamber with gases. This toxicity not only impacts the environment through the release of harmful particles and gases, but it can also have a direct negative impact on the health of workers and surrounding communities. Several commonly used chemicals are classified as carcinogens, while others are known to cause burns and respiratory problems, as well as pose risks to reproductive health. In response, semiconductor manufacturers typically have stringent safety procedures in place, including personal protective equipment, PPE, and ventilation systems, and must adhere to strict government standards regarding exposure monitoring and limitation. By accelerating processes along the entire value chain of manufacturing advanced micro and nano devices, localized direct atomic layer processing can drastically reduce chemical use and exposure. It combines the meticulous precision of materials deposition with accelerated deposition rates, all while operating in ambient conditions, thus turning traditionally lengthy processes into rapid, precise operations. The true value of localized direct atomic layer processing lies in the fact that it allows semiconductor manufacturers to skip a number of time-intensive steps, such as creating vacuum environments through time-consuming purge steps or eliminating cross-contamination, which again involves the use of chemicals. Simultaneously, manufacturers can accomplish a lot more in the individual steps that are taken, thereby reducing both environmental and human health impacts. By being more accurate and efficient, localized direct atomic layer processing represents a sustainable, environmentally conscious technology enabling zero-waste, advanced manufacturing of nano and microelectronics. Ultimately, this allows semiconductor manufacturers to work faster, smarter, and more ethically while making it easier to comply with government standards. Technological progress and environmental and human health are an ideal pairing. Will semiconductors' contribution to the long-term green transition be offset by the environmental cost of their production? Semiconductors are vital components of all electronic systems, from smartphones to cars. Yet the environmental cost of manufacturing them is becoming increasingly problematic. While this fact has been overlooked in recent years as the industry has prioritized supply security over environmental concerns, the issues of climate and human health are becoming more urgent in light of global production boosting initiatives. As the U.S. looks to increase domestic production within the current political context, localized direct atomic layer processing can be key to accelerating innovation, increasing the U.S.'s strategic resilience and reducing reliance on foreign supply chains, all while delivering a greener process. New advanced manufacturing methods such as localized direct atomic layer processing will be key to satisfying demand while protecting the environment and public health. You've been listening to Sustainability Soundbites from E+E Leader. For more information on sponsorship opportunities, reach out to our team today.